Okay, YouTube, in this video we're going to focus on a couple elements of matrix math, but the first one is just solving a system using an augmented matrix. So let's go ahead and construct our augmented matrix for this particular system here. So we have our coefficients 2 and 6 and 2 and 3, and then of course our constants here in this particular instance are 16 and 7. So here's our 2 by 3 augmented matrix here. And what we want to do is solve the system using elementary row operations. And so our goal in this case, in this video, another thing I want to highlight here is this. We're going to put it into reduced row echelon form. And recall that reduced row echelon form, at least for something that is a 2 by 3, something like this, would look like this. We'd have ones here and then zeros elsewhere, and then we would have some A and some B. But the benefit to doing something like this is we would know that specifically that A, B would just be the solution to the system, because we'd have here 1x equals A and 1y equals B if we put our variables back in. So we're going to go ahead and transform this into reduced row echelon form. We're going to start by getting a 1 in the top left corner. So I notice that if I want to have a 1 here, what I've got to have to do is multiply by the reciprocal of that current number. So we say half of row 1. I'll write that next to row 1 here. And I do know this. My second row here doesn't change whatsoever in this particular instance. Now half of row 1 would be scaling all these numbers by a factor of a half. So we'd have 1, 3, and 8. So now that we have this 1 here, what we're going to do is we're going to get all of the things below it to be a 0 using that 1. So we'll say multiplying the first row by a -2. Let me try this again. -2 times our first row plus our second row. That would get this term here to cancel out. So what we end up with here in this case is our first row isn't going to change. And our second row, we definitely have a 0 here. And then as far as what we have right here, we'd have -2 times row 1, which is -2 times this 3, which is -6. And -6 plus 3 is -3. And -2 times this 8 is 16 negatives plus this 7 here. So 16 negatives plus 7 positives, I suppose, would be a 9. So in order to put this in reduced row echelon form, our next step here logically would be to get a 1 for our entry down here, now that we have 1 here and zeros underneath it. So what we're going to do is this, exactly that. We're going to multiply this second row by -1/3. So -1/3 times row 2. And what we end up with is our first row, 1, 3, and 8, still there. 0 times -1/3 is still 0. This times -1/3 is 1, of course. And then -1/3 times this 9, or -1/3 of 9, is -3. So the difference here between row echelon form and reduced row echelon form is that now that we have a 1 here, what we're going to do is we're going to get zeros above and below it here. Now when I had this 1 here and I got zeros below it, I didn't say above and below it because there was nothing above it. But in this case, I want to get zeros above and below so that we have this zeros everywhere except for 1s down the main diagonal form. So what we're going to do is we're going to take this 1 times the opposite of +3. So we're going to take -3 times our second row, and we're going to add that back onto row 1. And before you get worried here, here's the thing. Row 2, by the way, doesn't change. But you're also not going to change the fact that you have a 1 here, because if you take -3 times a 0 here and add that to 1, you still have a 1. If you take -3 times this 1 here is -3, plus a +3 is 0. So we have a 0 there now. And -3 times row 2 here, so -3 times -3 is 9, and 9 plus this 8 here is 17. So what we end up with now is if we put the system back in here, we get x is 17 and that y is equal to -3. So our solution to the system here, the solution would be the point 17 comma -3. This would certainly be easy to check by plugging back into the original system, but you can see how we did this very quickly just by using elementary row operations and putting in RREF. Cheers.